Today, Human Element Solutions brings you the latest technology in whole body vibration. Our flagship board, the Arcwave, possesses several unique features that sets it apart from exercise platforms. In this video, we will demonstrate these features while giving you an inside look at the design of the Arcwave.
Looking at the inside of the board, we have used an off-center cam to get the oscillatory motion. It's basically acting like a 4-bar linkage, moving the frame up and down as the shaft rotates. In order to get the frequency and amplitude that our client wants, we had to increase the size of the shaft as well as reduce the RPM from the motor to the shaft. This is done through a 1.5 reduction from the pulleys. The top frame had to also be increased in size for our client's needs for the 550-pound load that they requested. The sizing that we determined would be adequate was a 1.25-inch steel tubing. This was designed with a safety factor of 1.5 in fatigue and 2.4 in static. The larger tubing was used not only to help with the increased loading, but also on the free end, when there was a max loading, that was where the maximum deflection would be. Thus, the larger tubing helped reduce the deflection at maximum condition.
The handle assembly is meant to support the user in case they lose balance. The clients requested that the handle be removable and adjustable. The handle has 3 adjustable heights, 3 feet, 3.5 feet, and 4 feet from the top of the Arcwave. All 3 heights will be set into place by a push-button locking mechanism. The handle also has a push-button lock at the bottom in order to lock into the Arcwave.
The platform here is designed for both functionality and aesthetics. It is made of plastic and a non-slip over mat that is snapped onto the top. The curved design on its top surface provides comfort for narrow and wide workout stances. The sides of the platform give an attractive look that embodies the metal, frame, and electronics. Underneath the platform where it is assembled to the frame, ribs enhance the strength of the plastic for heavy loads.
By taking into consideration our assembly objectives as well as manufacturing methods throughout our design process, we were able to implement many mirrored-like components as well as purchase components in order to reduce the amount of time and cost required at manufacturing. Our 2 main objectives within the assembly of this electromechanical device were to first minimize the number of components used while still maintaining full functionality. This applied for both electrical and mechanical components. Our second objective was to minimize the amount of assembly time required for each device. In order to achieve these objectives, we put much focus on making many of our components multifunctional as well as easily mountable.
The motor chosen to power this board is a 90 volts DC motor. It averages 1700 rotations per minute and is paired with one of Automation Direct's current input motor controllers. The remote operates on a simple Wi-Fi system that interfaces easily with Arduino's platform. The remote has 6 buttons and allows for different user inputs.
We hope that this was an informative and insightful delve into our design. We would like to thank our sponsors, Dr. Stephen Newhart and Mr. William Garner, for their support throughout this process. Thank you for your time, and thanks for watching.